In this video tutorial we are going to explain the operation of the tool developed by Cartief within the BIM-SPEED project. The 3-tool, 3D Automatic Surfaces Handling, Revit plugin, automatically detects and creates BIM entities, walls for now, from 3D point clouds, PTX, PTS, PLY formats, acquired by laser scanning or photogrammetry systems. The main use case for this tool is creating 3D building designs. To do this, scan-to-BIM techniques will be used, that is, 3D modeling of existing assets based on point clouds. This tool can be used by any professional who needs to quickly model a building in BIM from point clouds. Knowledge of Revit and point cloud handling is recommended, but in any case the tool is easy to use. The three main topics that will be detailed in the next part of the video are the installation of the tool, its use and the results obtained. To install this tool you need to copy BIM-SPEED folder and BIM-SPEED.addin file in this path. C:/program data /autodesk /revit /addins /version. Being version the year of Revit version, this tool has been tested for 2017, 2019 and 2021 Revit versions. Before using the 3-tool, a new project needs to be created within Revit in order to load a set of parametric elements to be used by the plugin later on. Once loaded, a specific icon is created in the Add-ins ribbon tab. Clicking on the Generate Project button, the plugin is launched and the loader menu is deployed. In this form, a browser is displayed and pressing Select button, the desired point cloud can be selected by the user. The format of the file should be PTX, PTS or PLY. In this example we are going to use a point cloud from the Warsaw demo site, about 15 million points. Once the point cloud has been loaded, the next button can be clicked after closing the viewer, displaying a new form where the pre-processing options can be chosen. The pre-processing form allows the user to modify the following options. Downsampling allows the plugin to operate internally with a smaller number of 3D points in order to speed up some steps of the process. We select 0.03 as leaf size, which will leave us with approximately 1.5 million points, 10% of the raw points. Filtering filters non-valid data and outlines from the point cloud. Offset forces the minimum coordinate, x, y, z, of the point cloud to 0. In this case we mark these options. Configuration allows to load, save configuration profiles. The pre-process button processes the point cloud taking into account the selected values. The final output is shown in a separated viewer. Once the result is validated, closing the viewer, the next button can be pressed, displaying a new form where the segmentation options can be selected. Of course, if the intermediate results obtained with the chosen parameters are not adequate, we can always press the back button and repeat the desired step by choosing other values. The segmentation form allows the user to modify the following options. Minimum cluster sets the minimum percentage of points with regard to the points of the main point cloud, which a cluster should have to be processed. In this case we are going to use clusters of 0.1%. Smoothness threshold, maximum deviation between the normal of neighboring points. We will select 3.2 degrees. Filter segments enables the filtering of the detected segments. We select this option in this case. Configuration, load, save configuration profiles. The segment button processes the point cloud taking into account these values. The display shows each of the elements found in a different color. The results obtained in this phase are very important as they will determine the walls to be created. Once the result is validated, closing the viewer, the next button can be pressed, displaying a new form where the analysis options can be selected. The analysis form allows the user to modify the following options. In layers, sets the minimum percentage or points that a segment should have to be considered as a valid plane. We are going to use the default value, 70%. Distance threshold, maximum distance between a point and the virtual plane to which it belongs. 0.1 meters in this case. Edge detection, maximum distance between the common edges of neighboring planes. In this case 0.1 meters. Vertex replacement, maximum distance between theoretical and virtual vertices. We select 0.2 meters. Configuration, load, save configuration profiles. The Analyze button processes the cloud taking into account the selected values. Once the result is validated, closing the viewer, the next button can be pressed, displaying a new form where the parameterization options can be selected. The parameterization form allows the user to modify the following options. Planes threshold, maximum distance between planes to be considered as neighbors. 0.2 meters in this case. Intersection, enables the auto-detection of neighboring planes. Normalization, enables the normalization of heights and offsets of the detected walls. We are going to select this option and use a value of 0.2 meters for the threshold. Ignore, discards walls with an area lower than the selected threshold. We are going to select this option and use a value of 0.4 square meters for the minimum area. Configuration, load, save configuration profiles. The Parameterize button processes the cloud taking into account the selected values. Once the result is calculated, the next button can be pressed displaying a new form where the project options can be selected. Finally, the project form allows the user to modify the following options. Wall type, sets the wall base type for the generated elements. We are going to select a generic wall of 0.2 meters width. Width, allows changing the width of the generated elements. Predefined profiles, load, save configuration profiles. The parametric elements generated by the plugin are part of the Revit library loaded when the new project was created. Some errors or warnings may appear, usually referring to the fact that some nearby walls have to be separated. In this case 91 walls have been created as shown on the screen. Thus, the extraction can be readily exported to IFC from Revit as well. Using the 3-dash tool to automatically detect walls from a given point cloud and generate the mesh of these elements allows anticipate time savings to the users. For the Warsaw demonstration project, the time spent for the automatic generation of the 90 walls was only 71 seconds. The accuracy and quality of the generated mesh is improved compared to traditional methods to obtain these surfaces.